But in that sense, you know, I'd love to open the floor, and if you've got a question to ask, feel free to raise your hand, and we'll get started. No questions. That was a quick session. All right. So, yep.
Just a general question. If you read anything today about big data, quote unquote, if you get 5 experts in a room, you're going to get 7 different opinions on what big data is or isn't. How do you define big data?
I define it as a marketing term that has no real meaning. But it's because the marketing term exists, it covers a certain set of situations. One of those is that there is out there, in various situations, there is a lot of data volume for certain things, and when we get the Internet of Things, there's going to be even more. You know, and that's clearly, there's going to be huge roll-ups of data that get to the exabyte level. That's going to happen. So that's the volume aspect of it. Another thing that's actually happening is the need for fast ingest or fast catching of data. Some of it is event data that needs to be processed in flight before it's caught. Some of it just needs to be trapped as it exists. So one of the aspects of big data is fast ingest, and we're talking about, you know, terabytes a day, and that's already. I think a jumbo jet with all its sensors at the moment generates a terabyte an hour or something. It's something like that. So that data is analyzable and is useful, and that stuff will be caught. If you can just push that out across all transport of any kind, you know, from the personal car to trains to boats, etc. You know, you can just see that there's going to be just massive amount of data that in one way or another gets caught and is useful in some way or other to be processed. That's the Internet of Things stuff, but all of that's going to generate, in certain instances, the data is going to be in flight, so it's going to generate fast ingest situation. You've got a whole series of difficulty around what they call unstructured data, by which they really mean not strongly structured data, in other words, not structured by metadata. That's not going to be properly addressed completely, if I understand it correctly, until we get semantic technology, which is now in the building. And there's going to be triple store databases and Sparkle and stuff like that's going to drive that particular aspect of big data.
I think we got a call-in question.
Or is that you calling a friend?
Phone a friend, yeah. Very, very good. So the other thing is that, and it's not talked about very much with big data, but the other aspect that we've got here is the fact that the data models that we built and the data that we store within an organization are reasonably well created and well looked after. And it's not that they're extremely well looked after, but we know how to do that. We don't know how to pull data in from outside the organization, structure it very well in terms of metadata, and combine it with the stuff we've got. So there's a modeling issue. And it's getting more confused by the fact that there's an awful lot of enthusiasm for schema on read out of Hadoop. So the idea is that, you know, we won't model it until we have to, and we'll try and get away with the least amount of modeling, and we will just in some way or other label this stuff as it comes out of Hadoop. Well, you know, if you actually want to pin down meaning, that's really, that's just crap. You know, it's not going to work very well if you're actually going to try and combine the data that's coming out of Hadoop with stuff that you've got within the organization already that's reasonably well defined, because you won't know when a join happens whether you're joining something that could be joined, you know, just because it had, you know, the same kind of column title as something else, you know. So there's an issue there with the modeling of data. There's an issue with the whole of data governance, because if you actually did data governance properly, you would start with the provenance of data, and then any time any item of data in any way or other changed, there would be a lineage of it, and every time you had an accumulation of data, it would be recorded what it was accumulated from, and there would just be a full lineage of data. Well, that just doesn't exist, but you will not get perfect data governance until that does exist. That's years away, you know, and one of the consequences of that is that people are going to do bad analytics because they won't know the provenance of the data, they won't even be able to prove the provenance of data, they'll come to bad conclusions, you know, and then they'll blame the software vendor. I personally will be blaming Yellowfin for most of it, if that's okay.
As well.
You know, so, you know, and this is like all part and parcel of the big data thing, you know, and then we've got the problem that in one way or another, what we're actually trying to do is you always in IT, you were always shooting at a moving target, and now the target's moving in a really, really big way, or it can be in some organizations, moving in a really, really big way. And the way that we did IT was to try and make it perform according to the latencies that are required for the various business processes, right? This is just going to become an awful lot harder. You know, and it's things like, we gathered all that data, but we didn't know it was useful. We eventually found that it was useful, and then we realized we gathered it wrong, so we have to restructure it in order to actually hold it in the right way in order to be able to exploit it, and that's just going to be repeated again and again and again, because we have no reasonable means of being able to get that data and organize it in a way that we know it will need to be organized in order to exploit it, because we don't know until we've explored it that it actually has the value it's got, you know. So all of that's, you know, part of the picture of big data, and it'll probably lead to a lot of consultancy. So I'm stuck being a technology analyst, and I'll take up the job of consulting because there'll probably be more money in here.
Just actually, I've got a follow-on question from that, which is a lot of what we see in the big data world, and so I think where a lot of the investment has gone into is fundamentally around marketing.
Yes.
So, you know, how do I make more money out of this data by selling more widgets to the population? And one of the things I think that as a result of that, I'm really quite fascinated in, and you touched on it before when we talked about the fact that Facebook is not regulated. There's not.
Yeah.
So what about privacy and all this? What do you think? You know, what do you think's, you know, when does someone come with a big stick and say, you know what, this has to be regulated? Data is something that has to be managed in a way, and has the US government got any right to tell anyone to do that anyways?
The US government is already bought, so I wouldn't be worried about it. It's bought by the people that own the data, you know. There is an issue which is like, it's a political issue, and it will arise at some point in time. It surprised me that it didn't arise a lot earlier. But the thing is, you know, I am a set of data, so are you. You know, every one of us is a set of data. Who owns it? Well, it's a really good question. Who owns that data? You know, I am Robin Bloor. Who owns Robin Bloor? Who owns it? Does the British government own it because I was born there and I've got a British birth certificate? Do they own it, or do I own it? You know, and questions like, if I go, you know, out onto the street and enter some shop or other and buy a pair of shoes, does anyone have the right to the knowledge that I bought a pair of shoes other than me? And it's a very good question, because you know, that's what privacy is really about. It's like, there's data about me, and I should be able to choose whether anybody knows it, you know. But there is no movement, there is no political movement towards the privacy of data and what that actually means. And then if you look at various countries and what they've done, the ones that care, rather than America that just wants to have a lot of people make money out of selling the data, you've discovered there's a different attitude in Germany to France to the UK. So even in the European Union, they can't agree particularly on this. You know, your emails, in Germany, your emails are private. Even if you're working for the organisation, no one has a right to read them except you. That data belongs to you, but it doesn't in the UK, you know, because your company is running the email system. But you know, if your company is actually doing it under Gmail, they can't get at your account anyway. So it's kind of like it's a confused situation anyway. And I just think that this is going to run for a long period of time. But when there's value in it, some people have got a lot of value in their data. And it's not obvious that they would, but it's like if you suffer from an extremely rare disease, your data is worth a lot of money. You know, and pharmaceutical companies will pay you for that data because there have been situations in the United States where people got together who all suffered from a given disease and started to ransom the pharmaceutical companies to do what they wanted, you know, or what that collection of people thought that they did. And it's like, we've never really, in any way, we've never really addressed this issue or even thought about it. And it's going to be a problem, but I don't know which way it goes. I don't know what's right or wrong. Do you have got an opinion what's right or wrong? Who owns your data?
Oh, I try to generate as little of it as possible, is the point. I think, look, I've been quite aware of my own privacy and the amount of data that I generate. And that's probably because I do work with data and understand what people can do with it. So, and I'm concerned about not necessarily me, but also the impact on my family is more the point of saying, well, if someone knows a lot about me, what can they infer from my family, etc. Which really is inappropriate, largely. Like, I'm not interested in that. So those are probably sort of my personal issues.
So I mean, you know, the privacy of data is much, much bigger than you think. I mean, one of the things that you may have noticed when you go on the internet now and you go onto a particular website you've never visited before, you're getting adverts thrown at you that relate in some way or other to you. Well, how did they know that?
Yellowfin.
I don't know.
No idea what's going to hit you.
The information that's in your browser that can be accessed by any given website is probably unique. All the cookies you've collected probably identifies you individually, you know, and therefore they can know who you are, and they've got various ways of matching up to find out who you are, and they don't really know who you are, but they've got the identity and they've got your history in one way or another of going to various places, and they can put the adverts, and they're making money out of you. Do they have the right to make that money out of you? Because they're selling adverts based upon information you didn't willingly give. You know, and then there's the deductive stuff. You know, the profiling that goes on is really, really fairly accurate. And if they know that in one way or another you bought this kind of car at one point in time, you live in this kind of area, and you like these kind of movies, they can pretty well predict what, you know, I mean, it's this in 1992 or 3, Littlewoods in the UK was like women that buy red shoes like black leather furniture, and they did, you know, and they were in one way or another they were able to kind of leverage things like that. And when you build a profile, you don't know how predictable you are, but if they build sufficient profile, they can predict particularly who you're going to vote for. So it suddenly did become political, you know, and they may also be able to predict whether you can be turned to vote for, you know, the other side, you know. And it's like, this is all people being manipulated by their data. And the reality is that we sort of own it, don't we? I mean, you own your data. You have that attitude. I have that attitude as well. I own my data.
Yeah, but on the flip side, I think there's a lot of people that don't really think about it, and so willingly give that up.
Yeah.
Because there's a perception of convenience. So coming to your point there, it was interesting. There was just a study released which was conducted by Google in India, which was in conjunction with Google in India, and using search terms for particular parties and where the search results turned up actually influenced people's propensity to vote. And so they had a population of 10,000 that they tested this on, and they were able to sway an election based upon Google search results. So to think that, you know, at a micro level we're not being influenced by our data and how it's being fed back to us is, it is something that is happening and will happen more. And the question is, how do we as individuals and think about that in terms of coming back to the whole big data space? But now we're heading into a lot of philosophy, which is probably not really the point of a technology conference, is it? But yeah, so we did digress then. Any questions other than that for?
Yep. As the
you mentioned a few times regarding the big data related to event-driven. I was just wondering, in the future, in the cloud or in the future database design, whether we need to take into account for the event-driven data, and how about the future system architecture should be taken into account event-driven as well?
Sorry, what was the last one? Event-driven?
Event-driven data.
Yeah. Oh, we're doing this, are we?
Yeah, I can't. The other ones, well, they're both.
So both broken.
Yeah, I know. It's the guy calling us before trying to get through. So,
the idea of the event is that, it's a fragmentation of what we previously called a transaction. So a lot of things in actual fact happen, which is data that can be collected that cumulatively means one thing, but individually also means a number of things. So the idea of building an architecture around that, I can't really talk about it because I was supposed not to talk about it, but there was a project that I came across in Boston, which was really certainly 5 or 6 or 7 years ago, and they just from the beginning they did an event-driven solution to the problem, and they ended up making a lot of money because they sold it. And they were actually using tandem computer. They was actually coding, in old style, but they needed to use tandem computer because they needed something that was fault tolerant, and at the time it was the only thing that was available that they could do that with. And it's like, once I'd seen that and talked to them about what it was that we're doing, and started to realize that, it's all about events. And then there's a question as to do events break down, and the answer to that is yes, they actually do. They break down into semantic triples. So there'll be a point in time where it won't just be events, it will be, in one way or another, it will be the breakdown of every kind of data. And that's this layer of, it's a pipe. I think it's kind of a pipeline architecture. And all of this data is in flight, and it stops in various places, and it gets processed in various places. And those are the systems we will build. And we never built systems like that before. And now we're going to do it, and there are a number of aspects of that. And one of the things is that you've got, data that is incrementally changing, but actually everything that is a change to data is just another event. So you've got all of these things that are actually making a difference to the shape of the data. And then you've got a massive amount of query that's trying to pull value out of the data. And that's all that you've really got. And all of the applications that we run right now could be described as being one of those two things, as more event data accumulating, or more queries being asked of data to allow us to come to some kind of conclusion, to make some kind of business decision. And that's a kind of an interesting way of looking at things, because I didn't mention the word database, and I didn't mention, I didn't even mention the word process, I don't think, and it's a really interesting abstraction because nobody ever looked at systems like that. And I've been playing with it for about 6 months this year and wondering what it really looks like. And there are all sorts of issues that naturally come in, and one of them is like, how are you going to govern that data flow? And then you look at the governance of the data flow, and it's like, well, we better clean the damn stuff. Well, so how do we know that stuff is clean or not clean? What are rules of governance that we can accept? That was weird, wasn't it?
It was.
Well, that was an event. The word, I never came across the term data governance until about 2002, 2003. Nobody cared about data governance. They didn't actually think it was an issue, and therefore I didn't think they had a word to describe it. But now it's going to be an issue, because when there is value in this data, you've also got the association of financial value with the data itself. So it should have an audit trail which is exactly like a financial audit trail. And eventually I think it will have that. There are a lot of data ownership issues in that as well. So it's like, this is just like unclear territory that is going to have to be discussed and be resolved in various ways, and Yellowfin will visualize it.
Thank you. Here's the envelope.
Thank you.
Any other questions? I've got, because again I've got another one, but then we're gonna veer again if I ask another question. So we'll veer. So we've talked a lot about the technology and this 1,000-fold. Does want to dial in, and this 1,000-fold, sort of speed and changes in performance. What do you actually think is going to be the societal impact of that? So I know you've got your head in the technology, but where does it all lead? Like what fundamental changes do you see happening in our day-to-day lives as a result of things going 1,000 times faster?
I mean, that's. You see, the thing is that you can make certain things go 1,000 times faster and other things you can't, you know. So it depends upon parallelism, but certain things are serial and there's not much that you can do about that in terms of the time. So this isn't a blanket 1,000, it's just that we have the technology right now with, you know, the CPUs and the memory that we've got.
Someone's telling you something.
Really?
Mm.
They don't want to hear my answer.
Don't want to hear
really
your answer.
my answer's no good.
Oh, there we go.
Okay, my answer's much better on this microphone. The I don't know. It's kind of I now got thoughts racing through my head, but there's a whole there's a whole series of business processes that are going to go faster and faster and faster, and the reason is that they are markets, right? So basically, if you're buying, if you want to buy a particular stock on a stock market and you put your order in now, and someone puts an order in a fraction of a second later, you get a specific price and they get a different price because your transaction changed the market price, but because you bought or sold some stock, right? So in that processing situation, you have the first person to put in, that is the lowest latency, wins. And there's a value in having the lowest latency, right? So that's a whole series of IT situations where the first mover gets the advantage, and therefore, no matter how fast it goes, they're going to continue to try and make it go faster, because there's always going to be an advantage to being first. And then there's the situation where human beings are involved, and we only have to go as fast as a human being. And that's a completely different processing situation. And there's no point in going 1,000 times faster. You know, it's like Google determined that it was 0.2 of a second, which was beyond that you start to feel that there's a lag in the answer to your search results, but below that you don't. There's no point in Google, you know, instead of 200 milliseconds giving you 10 milliseconds. There's just no win. Google doesn't win. It'll cost them a lot of money. They'll have to put in much more parallelism than they've got now to give you that kind of solution. No win. You know, so there are other areas where it will only go so fast. And then you get the complicated situation where you've got a business process and there are parts of it where, yeah, you'll go as fast as possible because it's process to process, but there's other parts where you're hitting a human being. And they have their natural latency, and it depends on what it is that they're going to do. You know, when you go to the doctor and you tell him all of your symptoms and he does his examination, he doesn't give you, in a fraction of a second, his diagnosis. He thinks about it, you know. And you wouldn't want him to do anything else, you know. You'd want him to think in depth about what it is that he's, you know, is trying to say about your state of health, so that the solution he proposes is most likely to be accurate. Well, that's just a natural latency, and it's not going to come down. You know, it is, well, the expert system that IBM's building with Watson might actually bring that down, but it's only going to bring down the certainty of a diagnosis. So there are those situations, and when you get many human things happening in the chain of situations, then maybe the business process is not coming down. You know, it's difficult to say. And if you kind of look at, you know, the development of something like the automobile has not really done much for about 40 years. You know, there's odd, really small parts of it that have improved significantly, but by and large it doesn't go much faster than it did. And if you're going from A to B, it doesn't handle much better than it did, you know. And yes, there have been improvements, but there have only been small incremental improvements. And there's going to be areas of IT that I think are like that, you know. It's just not going to get any better because there's no point in it being better. There's no big win. Have I answered the question? I'm not sure where I am.
Oh, you're close, yeah. Definitely.
Well, I think the follow-up to that is often a lot of the, particularly the very large vendors, talk about time to decision, and if you implement XYZ business intelligence or business analytics tool, you'll make a faster time to decision. Well, sometimes making a faster decision means you make the wrong decision.
Yeah.
And if you're making a strategic decision that's going to affect the company for the next 5 years, so what if it takes you an extra week to make the decision?
Yeah, and there's another thing, which is like, what is the optimum time in which to make the decision? You know, and that itself would be an analytical thing to try to find out. You know.
So,
Well, but yeah, I mean, you raise a really interesting point, because there are certain situations where it definitely is a considered thing, you know. And, you know, when you play chess at a high level, you're given, you know, 2 hours for 40 moves, right, you know. It doesn't say that, you know, on this move that you could spend a whole hour on it, because in making that move you just changed the whole, you know, game of chess. And it's like, it doesn't mean that you've got to, you know, if you've got 2 hours for 40 moves, it doesn't mean you've got to make a move every 3 minutes, which is the kind of thinking that you're pointing out is that people have got. It's like, oh, you know, really fast time to decision. Well, it isn't actually fast. It's to optimize the accuracy of the decision. I think that's really what's going on. But I mean, that's your point, not mine. I think you're kind of, I've already made it. I'm just giving you your answer back.
No.
At what point do you see the much vaunted artificial intelligence actually making the decisions for us on this? And
That's already happening.
but where do you define it as actually really being artificial intelligence as opposed to smart forecasting?
Well, there are different aspects to artificial intelligence. So if you actually look at the Watson project, you know, part of what the Watson project's doing is that they are doing the classic artificial intelligence chained reasoning, and on top of that, they're building really smart entry into vast amounts of research data. So in a medical field, right, they've got an expert system which behaves like a doctor, but when it actually looks for data, it isn't going to a rule. It's looking over, you know, thousands perhaps of documents that relate to a specific condition. So this is what made Watson special, was to link those two things together, because both of those things have been done before. But the two together had not been done before, and to actually put semantic technology in so that in one way or another the software itself could do reasoning with the unstructured, or if you like, the text. That's what they did, you know, and it's turning out to be very successful. So it's already here, and the depressing thing is that it only seems to be IBM that's got this. You know, so we've got just one player. It's always a bad idea to have just one player in the market, you know. So we've got that. There are some other things that are possibly worth mentioning. There's a lot of, you know, there's a world beyond the machine learning algorithms that can do really, really good analytics of data, which is I mean, I was having a conversation earlier, are we? There's a company in California that I went to talk to called ASD, right? And what they're doing is they're looking for hard problems, and what they are is it's a company of about 20 or 30 data analysts, and they're very good, you know. At least they're good enough to impress me. So, and this is what they do. They go after a hard problem. So one of the hard problems they went after was like all of the information on a network and working out what were attempts to compromise the network, attacks on the network. Well, it's a hard problem because there's a lot of data. And what they were doing is the data analysts looked at it and worked out which of the machine learning algorithms were applicable to this. And they ran them all, right? And they got results from them all. And from the results, they build a model which is actually a topology. It's actually a number of linked dots, right? And they maintain that this has all of the structure of the data in it, this topology. And that from this topology, you can resolve pretty much everything that's going on. In other words, they have mined the mountain and found all the gold in it with this model. Right? Well, the next thing is, you can now throw the data away because now we've got the model, and all we need in order to look at this going forward is the deltas, you know, the changes to any of this data, and we can update our topology as the deltas come in. So instead of actually having the data, what you actually now have is a topology that gives you a complete predictive capability on the behavior of a given amount of data. And that's got to do with having really, really accurate modeling of a situation and having reduced all the data to a certain level of knowledge about the realities of what really is going down. You know, I think that's the next step beyond machine learning. I think that there's going to be, and I had a conversation with some people here today, that just made me think that you know, which was along similar lines. It's just, that's where it's going. And that's like, you know, at this point in time, these guys charge, you know, whatever they want to take on a problem. They're only interested in people that have got, you know, at least 7 figures to spend. You know, it's not, for, as far as they're concerned, it's not about our costs and the software we use to get to answer. It's like, how valuable is the solution to you, and we'll take a piece of that. You know, and at this point in time, they can play that game. But later on, there's going to be data. If what they're saying is correct, and I mathematically can believe that it is correct. It's certainly correct in some situations. There may not be. It may be that in other situations not. I'm not sure that it's blanket correct, but in certain situations it is correct. Then you'll have data that's mined dry. We will have a complete set of knowledge about a given situation, and we will be able to keep it current, and that problem is completely and utterly solved. We never had that in IT before. You know. And I don't know where that goes, because that's a completely different world than the one that we live in now. Because at the moment it's like, oh, you know, we run this piece of data analysis, and out of it we get some kind of prediction that a certain trend is going on, and we refresh our data analysis every 2 or 3 weeks to make sure the trend is still going on. And it's so one-dimensional. And they're talking about a 3D, you know, a 3D topology of what the problem is. And our predictive technology is like one-dimensional at the moment. Well, it's a different world. Frightening, isn't it? I think you'll still be needed as a CEO of Yellowfin.
Thank you. I'm not going to replace my topology now.
No. I don't think they've invented a topology which actually replicate you. No.
Yeah, thank you. Thank you. Well, I haven't been paid 7 figures for you. Any other questions? Yeah?
Do you think the relational and dimensional data modeling is still suitable for the future big data?
What kind of?
Dimensional and relational database modeling is still suitable for future big data?
The future of big data is going to be in the triple stores. It's going to be in semantic technology. It's not there now. But you know, the reason for this is very, very simple and possibly quite easy to understand. If you think of a relational database, and you have a table in the relational database, and let's say it's it's a person table, you know, then you've got the metadata that says, you know, this is a person's first name, second name, address, staff number, and whatever else you've got in the table, right? That can all be reduced to a set of semantic triples, which says, you know, this individual has name Robin, first name has name Bloor, second name has address 1090 Sierra Oaks, and so on. You know, and each one, that particular record is just reduced to a set of triples, and then there's a number of semantic triples behind all of that that give you the meaning. Well, they were never in the database in the first place, so there are a certain, and that's like all the data that's arranged in databases in rows can be reduced to triples, and therefore you can hold it in a triple store and throw semantic questions at it. You know, but then you've got the fact that you can take War and Peace by Tolstoy and you can reduce it to triples, and you can ask semantic questions of that. And we could never do anything like that before, and that's where it's going to go. And what that actually means is that in the future, when they've got the technology right, and we are talking about possibly quite a way in the future, you're not going to model anything anymore because the semantics of it will self-model. So we won't need to do any, you know, modeling in one way or another. Well, at this point in time, we're so far from that in terms of the way that we're building databases and the way that we get swift answers to queries on databases that I don't really know how those two things get bridged. But the semantic technology is very real and it's coming, and most of the work to investigate it is now pretty much done. So there'll be over the next 10 years, there'll be a switch between modeling things in what we would think of as a relational way, which is metadata over data, to just having semantic modeling, and it knows. But you know, there's problems with semantic modeling as well. So it's like, and I probably shouldn't talk about them because I could go on for a long time about them. But it's like each individual has their own set of meaning that they attach to things, and we think that we understand each other when we talk to each other, but the level that we actually understand each other is not. We know when you actually do a semantic analysis of it, you realise that people do misunderstand each other a lot of time and do say things that are kind of ambiguous. But when you go from language to language, it's really broken, right? So it's like the Russian verb to hate, nenevidet, means to not look at. So when Russians think of hating someone, they think of someone I will not look at. When we hate somebody, you know, at least in the UK, like, we look at them and we think of hitting them with an axe. It's a different thing, you know. Our hate and Russian hate is different, you know, and that's a really extreme example, but I'm using it to indicate there isn't what they call an ontological problem with semantic technology, which is not solved, and they know it's not solved. And they discover that it works really, really well when you go into something like pharmaceuticals and you talk about drugs, because they have to be rigid. The meaning of those things has to be rigid. But when I'm talking to you, even answering your question, it's like I'm coming out with stuff that's not really that definite at all. And, you know, probably if you asked afterwards 3 or 4 people, what did he say, they'd probably give you 3 or 4 different answers. None of which made sense.
Sorry, do you have a question? No, you just raised your hand. That's all right.
What's the name of the American company?
IASDI.
IASDI.
AYASDI. And by the way, I came across an Indian company that's trying to do the same thing. So this is not, you know, it's not a secret source. People know this. You know, people know that there's something along this line. And it's like, you know, the reason that I tell people about this stuff is it's just really interesting. And we probably should know, because if we're involved in projects that have got a certain goal, and we realise that there's something that's, you know, compared to what we're doing is like you know, firing a rifle where ASD is dropping the atom bomb on it. You know, it's just a completely different order of magnitude. And knowing that this stuff is possible is just really interesting, and also knowing that they themselves are not sure how good it is because they haven't done enough. But they are reasonably convinced that their topologies are very, very, you know, they tell you a lot that you wouldn't get any other way.
Has he earned his return flight yet?
Sorry? Is his return flight? I don't know. I mean, he's just got to push on through this jet lag. We can torture him for more. Well, we're nearly at 5 o'clock, which is drink o'clock. So if there's any more questions for Robin, otherwise I'm sure he'll be outside having a drink and you can tackle him to the ground and ask him another question. Thank you, everyone. Thank you for a great first day, and look forward to seeing you tomorrow.